this video, we're going to update an example done previously with the new geometry nodes. Since Blender 3.2 doesn't support the old geometry nodes anymore, it only supports the most recent ones. If you remember, the first iteration of geometry nodes was something like a beta version, where we had a very different workflow that was always tied with attributes, which has completely changed since then. So we have a brand new set. So let's go ahead and see what we're going to do now. So this is the example previously. Now, if we open this example in Blender 3.2, you will see that none of these nodes work. You see that they're all red. So we basically have to update that whole aspect to work. So how did the previous example work? We have a grid that matches exactly the grid of our plots. We created an array in one direction and then in the second direction. Then we added the plots on top of that array. We added the buildings, and then we distributed some roofs. The plots, the buildings, and the roofs have their own collections. So we have a collection that contains all the plots, a collection that contains all the buildings, and a collection that contains all the roofs. In this case here, I did everything as a separate geometry nodes modifier. Now we're actually going to do it with one. So the first one we have here is instancing the plot on the grid, then putting the buildings on top, and we use a texture to randomize the height. So that's the old version. Here's the updated version. And it's very similar, so we have plots, buildings, and roofs. Now, I've done this quite different in the sense that we only have one modifier here, which is our city modifier. So if we click on it, we have all the information, which is essentially the same as what we had previously. So we have a grid, so that's essentially like two array modifiers. We have the plots, then we have the buildings, and then we have the roofs. And this element here is the randomization of the scale. And I've added something else which I think is quite important to learn how to do, which is having an attractor that changes the height. With geometry nodes, we can input a lot of data from the group input node, so we don't even need to have our node editor open. And we can see the most important information, or whichever information we decide to, directly within the modifier. That's also per instance. So if we duplicate this whole setup now, we can change these aspects independently. So we can have this as a little bit smaller, we can change the seed. Basically all of these options here that are exposed in the modifier, they're per instance, so they're not tied to the original geometry nodes data tree, but they're tied to the actual object. Let's rebuild this. So Shift A, mesh plane. Let's create a new geometry node and call this city. The first thing we're going to do is add a grid. So Shift A, search for grid, and we'll plug this in here. And now the grid, the way that it works is that this is a total size of X and total size of Y. What we need instead is to work with a cell size for X and Y. So we'll need to do that slightly differently. So Shift A, input value, and let's put 2. So that's going to be our cell size. And then Shift A, input integer. And now we decide how many of these we want. That's a lot. So 45, that's a pretty good number. Shift A, utilities, math. So we will multiply these two, multiply. And so that will be our total X and Y sizes. So we're making it a square grid. And then these are the total integers. Now, with the integers, we have to subtract 1. So Shift D to duplicate this multiply, plug it in here. And I'll say subtract 1. And then subtract 1 in here. The reason we do that is because there's always one extra cell. So now we have to double check if we have the right number of cells here. So first the size is 2 and then it's 5. So the size is not right. I think we need to add one. So basically we need an extra vertex because the number of cells and the number of vertices doesn't match. The vertex count should be one more because it's taking into account the last vertex position. For example, in this line here, we have 1, 2, 3, 4, 5, 6 vertices, but we have 1, 2, 3, 4, 5 cells. And that's why we add this extra bit here. Great, so this is our grid, and if we change the integer, it grows. So that's the first bit. Next, we want to add the plots. So now that we have the grid, let's instance the plots. So Shift A, instances, instance on points. So we'll plug this into here and let's add a join geometry. So search for join geometry so we can see both the plots and the grid. So we make sure it's going in the right position. Now we need something to go in here, and the plots, buildings and roofs, they're all organized in different collections. So Shift A, input, collection info, select plots and plug that into instance. Now it doesn't come out right. We need to change a couple of settings here. So first press on separate children, reset children, and then pick instance. And we don't need to see the grid because now it's correct. And that's how we have it coming up. And if we change the count, it changes, but you see that these are not random at the moment. They're distributed evenly across the numbers. So we want to add some randomization. So Shift A, search, random, value. And we want to change this to integer and put in instance index. Now we don't need to go this high because we only have how many items in this collection? We have 1, 2, 3, 4, 5. Okay, so this is good. And if we want to, we can always change the seed so we have a different instantaneous element. Great, so the grid is done. The next step is putting the buildings on top of here. And we're going to use this grid and we'll do the same thing again. So I'm going to duplicate collection info and instance on point. So Shift D. And let's select buildings. Use these as the instances onto which we're going to put the points. And let's add this to join geometry to see what's going on. So a couple of things we need to take into account. First off, we don't want all of our buildings to be everywhere because we have set up a vertex group within our plots onto which to place the buildings. So some plots have a VG buildings group and some don't. And I've duplicated this first one 3 times just so we get more instances of plots with buildings. If we go into weight paint, you can see the red is the only area in which we want the buildings. So how do we get that captured into here? We have to use a node called capture attribute. So Shift A, attribute, capture attribute. And we want to plug it in before we instance the plots. So it has to go over here. And now we have to specify the vertex group from which we want to capture the attribute and use that as a selection for our instancing. To be able to select the vertex group, we have to put this as an input from the modifier group. So I've erased the group input, so Shift A, group input. And now let's drag this into here and we have a new value, and you see this is exposed within the modifier. Let's rename that and call it vertex group VG buildings. And now within the actual modifier, if we click on this icon, it makes it an attribute. And now we have to type manually VG underscore buildings because that vertex group doesn't come from this object itself, it comes from a different object. Now that should be captured. Once it is captured, we can use the attribute as a selection point. So if we click on selection, you see that we are only now getting these attributes on those specific selections, which is great. It allows us to filter out information. Instead of just instancing on points here, because these look too uniform, we can distribute on points prior to instancing. Shift A, point, distribute points on faces, and let's plug that attribute selection into here. And that's fine. The scale is very large, so we can reduce the scale. First we'll do it uniformly, and then we'll start to play with it randomly. Great, so now we have our buildings. The next thing we need to do is put in our roof details. The roof details work in a very similar manner as the buildings. So within the buildings, there's a vertex group called roof, and each building has that. And that's just the top where we want the roof parts to go. And the roof is a collection which contains these 3 different items. So let's click on our grid here again. And let's duplicate all of these items, plug in the instances, change the collection to roofs, and let's plug this in. Now, right now we don't have much roofs because we need to specify exactly where they go. So we need a capture attribute again. And we have a different issue. You see here we have an exclamation mark, which is saying collection contains current object. So it cannot work if we have our current object here. So let's rename our current object to grid, and let's place it in a more general collection that I have, so it doesn't interfere. And now if you see, we have a lot of, what do they call them? Gibbles. In fact, my computer is crashing a little bit, so I need to lower this density down to something like 1. A bit better. There's still a lot of them, but let's filter them out. So to filter them out, we need to do the exact same thing that we did prior. So with the collection info of the buildings, we want to capture the attribute. So I'm going to duplicate this capture attribute and place it here. And again, the input for the attribute, we need to plug it in into the group input and change this to, I'll call it VG roofs. Now let's go and see what we named the vertex group. It's very important when we do this that all of these buildings, even though they're different, they have to have the vertex group being called the exact same name. In this case, it's called roof. So if we go into our grid, click on the modifier tab, VG roofs, let's select this icon and type roof. And now let's use this as the selection. And hopefully we should see our roofs appearing only where they should, which is on top. Great. So our base is done. So what do we want to do now? We want to do a couple of different things. One is let's vary the height. We'll vary it randomly and then with a noise texture. And then let's add an attractor, which can be controlled by this empty here. And to show you the example that I've already set up, if I turn off this grid and turn on this grid, you can see how it works. If we move the attractor, the height and the scale changes of our building. And let's start putting in the attractor. Prior to that, I want to start organizing this file because we are starting to have quite a few things going on here. And right now, it's still fresh, so it's clearer to understand, but with geometry nodes, the idea is that we build less and we can recycle a lot of the examples. And that's exactly what we want to do here. So first, with the Node Wrangler add-on enabled, I'm going to select all of these and press Shift P, and it's going to group them. Let's go to Node, uncheck color, and I'll call this grid. Next, let's group this. Shift P, plots, Shift P, buildings, Shift P, roofs. Great, so now we have all the items that are necessary to make this work. And then we have our group input here with the vertex groups. So let's start randomizing the height. We'll do that within the buildings and within this instance here and this rotation. So one way we can do it is with random value. And if we plug this into scale, it's not that random. So that's the only trouble with it, that as you can see, it can do a better job with having something a bit more random. I'm going to increase the resolution here a little bit. So another way we can do this is with a noise texture. Shift A, texture, noise texture. Let's unplug this and plug that into here. And if we change the scale, we should be able to see how some buildings start to vary in height. So the larger the scale becomes, the less refined it is. And the idea here is that we add a bit more randomness into the scale. And next, let's add the attractor. So Shift A, input, object info, select the empty, which I've called the attractor. Make sure we change location to relative. Shift A, input, position. And what we'll do is measure the position of each point on which a building is distributed to the empty. And then we'll map that distance to a scale factor. So next, let's measure the distance between the two vectors with vector math and change that to distance. Put in position on top, location on the bottom. So where does that position come from? It will actually come from the positions of the points, and that will get picked up in this node here. These are called fields, and those fields, they get picked up backwards. I mean, we have to read the flow from wherever it's picked up on. Diamonds means that they're fields, and right now it hasn't been computed because it hasn't been connected to a node that can calculate that information just yet. So now we want to create a map range. Plug this value in here, and we can see if we have diamonds, that means they're fields, and those fields get carried through all the nodes until they get plugged into a node that can calculate them. From values are the distances, so we'll probably go to something like that, and to values are scales. So the scale is actually going to be inverse We're going to use this noise texture, but before we do, let's plug in this map range just to see what's happening here. And right now we don't see much that's happening, but it is being calculated. And we can tell vector field based on position attribute from geometry. So it's telling us that it's coming from here. This is the geometry. It's getting picked up. And from these points, it's using this position. So why can't we see anything? We have to do something here, and we have to realize the instances. Because we instanced these on the plots, they're not coming through. So it's hard to understand where those positions are. So if we go to Shift A, search, and then realize instances, plug this in here, and now we see that it has the effect that we're looking for. I don't know why this is happening. It took me quite a while to find it out, but that's how we can avoid that. So now we want to soften this, right? We don't want everything to be 0 and max, and that height is probably a little bit too high. So we want to edit this height a little bit. And in fact, what we want to do is add this to our noise texture, but we want this to be only Z. So what am I saying? We basically have to add whatever range we're getting to here. So to do that, let's copy this distance node, Shift D, I'll plug it in here, and we can say add. So it's just a simple vector addition. Noise texture will be on the bottom, and on top it will be map range. But we don't want this to go completely on the top like this, because then it scales in all the axes. Let's scale only on the Z axis. So Shift A, vector, and combine X, Y, Z, plug this in here, and change this to Z. There you go. So now that's only affecting the Z, and it's only affecting it locally. So you see, now we have the effect that we want. If we want to change how much it is attracting it, or how little it is attracting it, we can change this maximum value. So you see, if we increase the maximum, the sphere of influence increases. And if we increase this to minimum, then the scale gets increased. And if we increase the max, then they all start to grow. We can even grow negatively, but I think what we have for now is fine. We want to make sure that we leave clamp point, otherwise we get these negative results. So if this is like 1.5, then the impact is less. So we're done over here with our example. Let's continue with our organization effort. So I'm going to select these, Shift P, and let's call these attractor and scale, and then check color. So we have all the parts to make this work conveniently. Next, let's expose some more parameters within the modifier. So if we duplicate this, we can change some settings. One good item to have access to is the cell count. If you press and hold Control and drag these over, let's plug them in here, and let's change that value now to 5. And now we have a grid size of 5. Let's rename it. So if we go to group, I will call it cell count, and change the type from float to integer. Let's change it to 7. Great. The next thing that would be useful to have in here is the seed of our plots. So if we want to, we can change the plots. We have a couple of places where we're using seed. So we're using a seed value here. We're also using a seed value for the distribution of points and for the distribution of roofs. So what we can do is actually connect all of these seed values to one value that's going to connect our seed. In this way, we're guaranteed that if we have one aspect, it's going to look quite different than another. So let's duplicate and just test, Shift D, and we'll put this somewhere over here. So what can we change now? So let's change the cell count to 15 and the seed maybe to 0. Great. So what if we want to adjust the attractor? So we can do the same thing. The attractor comes in from here, and we can have multiple attractors. So if we plug in the attractor input, and now that's being specified. So if I duplicate this attractor now, Shift D, put it somewhere over here, go in the second object and change it to attractor.001. And now we can see that that's being modified as well. And lastly, we might want to include this minimum value, which is our height of the attractor. So to minimum, the default is 1.5. So in this small instance, we can say something like 3. We can plug in more, but the idea is that we don't put every single input that we have within the modifier, but we put only the ones that we believe are the most important ones. For example, 2 maximum might be also a good one to have in there. Great, and thank you very much for watching. This file is available on Patreon and on Gumroad, and your support means that I can invest more time into creating videos like these. If you're interested in geometry nodes and in some specific topic, please let me know in the comments and I'll be happy to research it and look into it. Cheers and bye bye.